what we do over here, we see the Alice, and then it's it's doing this operation Z, where it's gonna like look at the particular object, and um, fundamentally you need to go through hashing, and then before you get added into the list over here. So that's what happens. um, so this guy over here, it'll go through hashing. So at the start it may be some form of like represented ASCII alphabet. So operation Z is that we make the name using ASCII to actually convert it to integers. So maybe at this point it will become like maybe say 27, and the next step is like operation X. We're gonna use a formula, and the formula will be doing of like modulus, and once we do the modulus thing, the next thing that we know is and what we're gonna modulus with, like our current index slots. So our current max index, maybe for this case it would have been maybe say 2. So I mean it will give me like the remainder of maybe say 1, right? And now we have like the answer. So the next thing, operation Y, slot in the answer to index. So for this case it will be say this one over here, which is my Mr. Alice, right? And New York City. And then we go on to the next one, operation Z. We convert it, yada yada, modulus it, slot in, and it happened to be 3. And then next we go to colon, and this time around it will detect that, oh guys, we are inserting more than 2 of our folks. I think at the start it was like within this range. So what happens is that, oh right now we have my idea is this, like the moment is like more than half. So operation E is that if you say like more than say half of the storage occupied, then we start to do actually a multiply by 2 for the storage. So I think initially it was like maybe say 2 slots, it then became 4 slots, and then 4 slots, then it became the 8 slots. So yeah. And one more thing is that like we will actually put a like prime number for the storage as we do like the multiplications of like 2 of the storage. And the reason why we actually do this is because like there's like a math logic to it. So you say that you have like a prime number, so they tend to actually put prime number is because that usually when you do like modulus with this guy over here, you usually get like result yourself into getting like some kind of like remainder. And then if you got like a lot of remainder, and that will actually result you in having maybe say less collision. So I think that was the idea, if you say that like you want to use a prime number for the storage. But for this case we're doing the simplified version. So anyways, as we were adding, we add until Dylan, we expand until like maybe say 8 slots, because each time that we add a name, we're gonna keep on expanding. I believe it's like more than like maybe say half. So we came here to actually say we want to add Colin, right? So go through the name ASCII, we have Colin, we have 33, we do the modding, and now our current mod storage is 8, and then we get a 1. So now the thing is this, we enter here, someone is like occupied, so what we do is like the method of like open addressing. So another operation, which is like operation E. Okay, my slot is like maybe say occupied. So what I actually have to do is open addressing. So we will open addressing, we come to here, oh, it's been taken, there's an Alice, go to the next slot, is it empty? It's empty. So like fundamentally what it checks is that is say the slot taken. So if the slot is taken, so if it's like yes, then move next slot. But there's chance that there's a no, right? So if it's no, then I just gonna slot it in. So it asks the question, obviously that yes, it's taken. Go to the next. No, it's not. So I'm gonna just insert it. Colon to be here. It's under C. And then maybe say now we have Dylan, right? And Dylan maybe it may be containing one as well. So check here. Yes, it's taken. It's not. Check here. Yes, yes. And then no. And then finally I put a 4. I put a Dylan over here based on whatever country it is. Right. So why we do this open addressing is because that obviously for obvious reasons to prevent collision, to also maybe say address collision. So this is very much of an importance to us, right? So um, um, yeah. So and I mean it's just this is like one of like the maybe say one of like the method to actually settle for collision. And I think so this is maybe say like the method 1. There's also maybe say like a method 2, which is to combine in the value section to actually create this place. And how you actually combine them, you can do it like through linked list. So you just kind of like combine them. So you have like multiple values that's been stored. So maybe at least like colon will be storing at the same place. So that's the second way we can actually do it. Yeah, so and the reason why we sort of need to make sure that we constantly multiply it, I think it just follows very much of like the logic of arrays, right? The logic of arrays. So meaning that like it has this constant wanting to actually make sure that you actually um, create enough like slots for like maybe say for incoming entries, right? You are trying to strike the balance of saying that creating too many and as well as creating enough slots for them to actually come in. So that's why like each time you reach until a certain threshold, you multiply it. So that's the idea. this whole thing is about like all the fundamentals of like maybe say doing hashing, and I feel like whatever they are trying to actually do is at the end of the day, I mean it's just like we are talking about the core concept about doing hashing, right? All these guys, they are all they are talking about is maybe say hashing. And why do we actually do hashing is to actually make sure that we have like a, a system where we can actually um, transform, in this case is a name, into a relevant index, and with the relevant index we can store it into the storage, and we're having a system is to make sure that this guy over here, these guys are over here is being stored, like maybe say efficiently, and we're doing it in a very systematic way, and um, we are taking care of like maybe say less collision by using certain formulas, maybe say the prime number. We're using the modulus to make sure that okay, always they will actually have effective number for them to be planted into, and when there's like number collision, we have like a system in place to make sure that okay, um, we're gonna be able to move down when needed, or maybe even do some form of linked list. So yeah, with that I think this is a lot to do with like maybe say the concepts of maybe say hashing, and it's under the map of maybe say hash map, right? So yeah, everything comes to an end.